Okay, so we're now recording. And so this is for the future teachers, and I will get to the rest of you all right after this. So it shouldn't take very long. Okay, here are the various assignments that are due. All of these assignments are due except for the article review 3. Everything else is due obviously on the 13th. I just need to change the due dates for those. But don't worry. So you all will be doing a Globe assignment, outdoor weather data collection. So you click here. This assignment is for students planning to be teachers only, so there hopefully be no confusion. And so here is Globe Assignment 1, Outdoor Weather Data Collection. Go to Student View, view a student, which means I have to start over. So again, here I am as a student. Not much different. Click there, click there. Okay, so here's a student view. So here are the various parts of the assignment. So here is the Word document, Globe Assignment 1, Weather Data Collection, Outdoor Exercise. I'm going to go through the basics of this assignment. Obviously, the main objective is for you all to learn as much as you can about Globe. Remember the Globe program, Global Learning and Observations to Benefit the Environment, is a federally funded program, primarily funded by NASA. The primary objective is to improve science education at the K through 12 level. Tennessee State University produces more teachers than any other HBCU. However, very few of our graduates choose science teaching as a career. Do you have to be a scientist to teach science? No. But we would hope that you have at least a rudimentary level of understanding of science so that you can perhaps become a science teacher. Why is it important? What is our role at Tennessee State University in this project? Well, my role as a Globe trainer, the overarching role is to close the racial achievement gap in science, technology, engineering, and math. So for instance, only 3% of doctors are African American. 3%, even though we make up about 16%, well, we make up about 13% of the population of the country. So we're grossly underrepresented uh, in the medical field. And so it should be come as no surprise that you see African Americans dying at alarming rates from COVID-19 due to what we call comorbidities or existing health conditions. And a lot of the existing health conditions that we have as African Americans are completely preventable in some cases. So why do we have these diseases? Are we just predisposed to be sick? Is it in our DNA? No. A lot of it is because we do not have equal access to healthcare. And that's essentially what is killing us right now because we have not produced a fair amount of doctors. Now, of course, we've had a lot of reasons why we don't have equal access to anything in this society: slavery, Jim Crow, mass incarceration, et cetera, et cetera. However, we cannot let those obstacles stand in the way of our success and our excellence. We cannot, because it's a life or death situation. Where do we get more doctors? Where do we get more engineers? Where do we get more astronauts? Teachers. So those of you who are teachers, you're the ones who create all of the professions that we see out here, right? Without teachers at the K through 12 level, there wouldn't be any black astronauts, there wouldn't be any black doctors, there wouldn't be any black scientists of any kind. So our mission is to try to convince some of you all to at least teach some science, because maybe you'll be that person that sparks that curiosity in that child that says, you know what, I think I'll want to be an endocrinologist. You know what, I think I want to be an oncologist or what have you. It's teachers. And the research shows that the best way to get black children interested in science is with Black teachers. And you can go look that up. You know, oh, that sounds racist. It's just the reality. And that goes for just about anybody, right? So that's why you're doing this, to get you to do a little science experiment. And hopefully you will do this same type of exercise in the classroom with your students, even if you're teaching kindergarten. When the Globe program first started, it was only for middle school and high school students. But then K-5 teachers started to say, hey, wait a minute, our children can do science too, even though they're 5, 6, 7, 8 years old. And really, that's the time to get children interested in anything. It's when they're young, they don't care. There's nothing nerdy about being a scientist when you're 6. You just want to be a scientist. You know, it's not till we get older that we start worrying about what other people think. And I don't want to be a nerd. I don't want to be a geek. I don't want to be too smart, right? So when you get older, but when you're a child, and children just want to learn everything. You know, that's probably why you all are preferring to teach 3rd and 4th and 2nd grade and not deal with the older kids who are like just, you know, doing their thing. Okay, so let's get into the assignment. That's enough of the rationale. Okay, so this is an outdoor exercise. Before you go outside, and this you all should be good at this. You'll put an app on your mobile device. And so you'll get the Globe Observer app. And so I have it on my phone here. I don't know if you all can see that. Let me see. So here's, I don't know if you can see. So the Globe Observer app is right there. Just get it onto your phone. It's the first thing you'll do. So it's called the Globe Observer, and all the instructions are right there for how to get the app. That's before you go outside. Next, you'll want to review the instructions for conducting a globe cloud observations using the Globe Observer app. So just read the instructions before you go outside. You might want to do a test run, okay? It's a pretty easy app to navigate. Again, if you get stuck, get into a jam, call me, text me. Even if you're outside trying to do it, call me. Hey, doc, don't say hey. Good morning, Dr. Padgett. I'm trying to figure out how to use the Globe Observer app. I'm out in my front yard, or I'm on campus. Can you help me with X, Y, and Z? No problem. I'll do that. That's before you go outside. The next step before you go outside is to go to this Weather Underground site and go to the Weather Underground site and come on now. Okay, here we go. The Weather Underground site. So the Weather Underground site is a web page that has the weather stations, not official weather stations, but lots of people have. There are weather stations that on schools. Tennessee State University has a weather station on top of Hale Hall. So there are lots of weather stations out there. So somebody just give me your zip code area. Anybody?
37211.
37211. All right. So go to 37211. Boom. Click there. And there's a weather station at Villages of Brentwood. I think that's probably an apartment complex. And so then you'll take this link and then you'll copy and paste that link just to save it for later, right into the Word document. Boom. And there you have it. So there's the nearest weather station to you. Now, that's not the official weather station. That's the weather station that's at that apartment complex. Okay, do those 3 things. Now you're ready to go outside. So you'll be prepared to be outside for about an hour. Don't think you're going to do this in 10 minutes. So you'll make a globe clouds observation using the globe cloud chart. And so as you're doing this the entire time, think about how you might engage your students in this assignment. You know, just keep thinking about that world. So here's the globe cloud chart. And, you know, children look at clouds all the time. And so, you know, you might say that cloud looks like a bear, that cloud looks like whatever. But different cloud shapes can teach us a lot about atmospheric conditions. So now we get children thinking about the atmosphere, thinking about clouds. Why do clouds form? Why does the sky look the way it looks? This is when we get children to engage in what we call scientific inquiry, which is just basically asking questions about things that we see every day, like clouds. So here's the cloud chart. And then you will do a globe observation using the atmospheric investigation clouds 1-day data sheet. Now you'll probably have to print this out. Well, you'll definitely have to print this out. And then you just fill it out, your name, the study site, maybe it could be just your neighborhood. Don't put your home address here. If you're on campus, you can just put Tennessee State University at study site. The year, month, and day, very important. Then the local time, hour and minute. Don't worry about the universal time right now, just local time. And then using the cloud chart, you can look at what percentage of the sky is covered by clouds, and you just use the cloud chart to estimate, look at how the sky looks, what percentage of the sky is covered by clouds. And so then you would check that off on your sheet. And then visibility. And so you can just fill this in with a pen or pencil. High level clouds, mid-level clouds, if you see them. And again, this is not an exact science, okay? You're using the naked eye to make observations. After you practice this for a while, you will get a better idea of how to do this. Is there snow or ice and so on and so forth? Now, the temperature, you can get the temperature from your that weather station nearest all these, the temperature, barometric pressure, humidity. You can get all of these values from the local weather station and just fill those in. So you can either do that after you go back inside. You don't necessarily have to do it while you're outside, although you could if you access the information using your mobile device while you're outside. But you don't have to have the temperature and barometric pressure and relative humidity at the exact same time while you're out there. You could, but you don't have to. Maybe as soon as you go back inside, get those data. Okay, so once you fill this sheet out, you can take a clear photograph of it and then save it to your hard drive and then submit it to the Dropbox. So that's part of the assignment. So now, again, as you're doing these, making these observations, think, how can I implement this in the classroom? How would my third graders complete this assignment? Because obviously you're an adult, you have a different level of experience and understanding, but how could you make this an interesting assignment for a second grader? And also, speaking of that, I mentioned earlier that Globe at first was for uh, middle school and high school students only. But since elementary school teachers raised their voices and made it known that they want to be involved in Globe, Globe has created an entire series of elementary Globe exercises. So if you go onto the Globe website, which is Globe.gov, www.globe.gov, which is the first part of several of these links. Go in there, search for elementary Globe, and you'll see that there are cloud exercises that are specifically designed for first graders, second graders, third graders, fourth graders, and so on and so forth. So just always keep, you'll see why in a moment. Okay, so you've done A, you've done B, and then now you're down to C. So at C, this is where you will use the Globe Observer app. So you'll do the exact same, make the exact same type of observations that you did by hand, but now you're going to use the app. And so you'll open up the app. And again, be patient, okay? This is not something that you're just gonna go bam, 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 and be done with right away like that. Maybe some of you will, but if you get stuck, be ready to get stuck, okay? Nobody does this the first time easily. Just hit that app, Globe Observer app, and see the Globe Observer app opens up. And part of the reason why you should do a dry run first is sometimes it's the first time you use this app, it updates and does all this updating stuff, you know, so you want to make sure that that doesn't happen when you're ready to go outside and really take your observations. Okay. And go to next, and then you have to do a login and all that. But you know, once you get everything set up for the app, and you should probably do that before. See, it says here create an account. You should probably do that before you go outside. But then once you've created an account, then you're ready to go. You log in, and then you'll just follow the instructions. And it's an iterative process. You get prompted. It's not like you have to search around a lot. But again, if you get stuck, let me know. Okay, just don't stay out there and be stuck. You know, I don't want you to get caught up in being stuck. Okay, so now here's the interesting part. After you make your Globe Observer app observations, within a couple of days after you complete your observation, you'll get an email with a NASA cloud observation and satellite match. And so here is what that looks like. So you'll get this. This is a sample one. So notice what you get here. And this is what really excites kids when you do this. So here is your observation. This is what you'll get. So here is, let's say, the observations that you enter into the app. Okay. And then you'll take some pictures with your phone and everything. So that in green is what the, let's say what you saw. And what is in yellow is what a NASA satellite saw. So there are several NASA satellites that are orbiting the Earth that are sensing clouds. Remember remote sensing? They're sensing clouds at the approximately the same latitude and longitude where you are. And so what you'll get is what the satellite sees versus what you saw, right? And so notice on this one, the satellite saw no clouds, no clouds, no clouds, no clouds. The student saw a few contrails. Let me explain what a contrail is very quickly. A contrail is a cloud that is left behind by an airplane, okay? Why do we even consider looking at contrails? Well, for a long time, climatologists wondered if contrails had an effect upon weather and climate. But it was difficult to have a control over that because there were always planes in the air. And there are websites you can go to, and you will see that there are a whole lot of airplanes in the air all the time. So scientists didn't have a chance to see what would happen if there were no planes until September 11th happened. And so after September 11th, for maybe 4 or 5 days, there were no planes flying in the entire world. Nowhere, no planes. That was the first time that ever happened in history. So scientists were able to see the atmosphere without planes versus the atmosphere with planes at the same time. And we're kind of seeing that again now with COVID-19, because COVID-19 basically eliminated commercial air flights by 90%. So it wasn't a 100% reduction in flights, but a significant enough reduction that differences in climate were observed when there weren't any planes. Differences in air quality could be observed when we didn't have all those planes flying around. So that's why we look at contrails, because they do have an impact upon the atmospheric ecosystem. And so if you notice, the students saw not a few high clouds, few cumulonimbus clouds, a few mid-level clouds, a few altocumulus clouds, uh, a few stratus clouds, right? But the satellite didn't see anything. So this just shows us that even though we have a lot of technology today, satellites, all of these computers, but we still need human beings to do hands-on science sometimes. And so that really gets young children excited, because sometimes we feel as if we're insignificant because these machines can do everything for us, right? You can go to the store and not talk to anybody. Go in, pick up your item, do your Google Pay, tap your phone, and roll out of there. You know, no cashier, no salesperson, no nothing. Or you don't even have to go to the store. You can shop online, right? Don't talk. But we still need human beings as scientists to do things hands-on. We can't expect for computers and machines to do everything. And so this really gets young children engaged. And hey, the satellite can't see anything, but look at what I saw. And then when you really, when you take these observations, the observations don't just stay on your phone. They actually get uploaded to the Globe data visualization system so that people all over the world can see what you observed as a Globe observer. And so it really gets children feeling like they're part of something larger than themselves, you know, science, the world. And that's why Globe is called Globe. It's literally a global, worldwide program. There are over 30,000 Globe schools all over the world. How does a Globe school become a Globe school? Well, when you become certified as a Globe teacher at the end of this class and you get a job at a school, that school becomes a Globe school because you're a Globe teacher. And then hopefully you will continue to impart scientific knowledge upon your students in that way, shape, and form. And maybe a few years from now, we'll see 6% of doctors being African Americans and maybe 10%. And the world is what it is. You might think, well, how come we need Black doctors to serve Black communities? That's just the way it is. You know, those graduates, those MDs who graduate from Meharry down the street from TSU, they are far more likely to work in our communities than any other doctor, you know, far more likely. So you teachers play a role in that. You know, you teachers play a role in that. Okay, so after you've done all the outdoor parts of the activity, then you just answer a few questions. How did the weather conditions you observed compare to your local national weather station forecast? Okay, so what you're doing is, remember that step D is to consult the local weather forecast for your location at your national weather station site. Now, the national weather station site is the official government site. So what we're doing is we're comparing our observations to the official site for the government. And let's see if there's a difference. So here's a National Weather Service site there. It's weather.gov, pretty easy to remember. Then you can either type in your zip code location. Let's see. So that was 37211 was that last one we got. And that's, let's see, that's basically, let's see, that's Cane Ridge, Tennessee, lots of places go. So this is the weather station that's at the Nashville International Airport. So this is the official government weather station. So the question is, when you look at the forecast, let's say, was the forecast that you saw on that day, was it sunny? Did you see clouds? Was the temperature about the same as at the little unofficial weather station? Those are the kinds of differences that you're looking at. You know, was the humidity the same? You know, and there might be differences. You might see a difference between what you see at the official weather station and your observations and the little weather station nearest you. And then just write down your observations. If there are differences, maybe provide some possible explanations. One explanation is that the Nashville's airport is outside of the city. It's a very wide open area. Whereas where you are, you might that weather station, that apartment complex, there might be a lot of concrete there. So that's going to make a difference in the temperature. Your local weather station obviously is not in the same location as the official weather station at the airport. It might be sunny at the airport and cloudy where you are, right? It might be raining at the airport and dry where you are. That happens. I'm sure you all have noticed that on some days where it's raining in one place and you drive across town and it's sunny. So just, that's question number one, or A. How do your globe cloud observations using the Globe Atmosphere Investigation day sheet compare to the NASA Globe Observer Cloud match data you received? So then this is when you look at this image. And again, if it was this one, you'd say, oh, wow, the satellite didn't see any clouds, but we definitely saw a few, even though it was less than 10% of the sky covered. I found that very interesting. This is not I, it'll be we if it was you in your class. Did you notice anything else interesting? Were there lots of contrails? Was there a thundercloud? Well, really, if there's a thundercloud, you shouldn't be outside. But other than that, was there anything else? Was the sky unusually a different color? I don't know if anybody in here, nobody in this class is out west, but I know that there are lots of fires out west. Or maybe wherever you are, there might be, I don't know, something that releases pollution. Anything else that you saw that was interesting. Was it unusually hot? Was it unusually cold? That's what you would put at C. D is open-ended. Did you learn anything? The answer to that question cannot be no. Didn't learn anything, Dr. Padgett. No, you have to learn something. What did you find most interesting? That answer cannot be nothing. I ain't learned nothing interesting. No, you had to find something interesting about this exercise. Did you encounter any difficulties or challenges? I'm sure you have an answer to that. And then finally, how would you modify this lesson for your students at a specific K through 12 level? So let's see, Hayes, 3rd grade, Robinson, 2nd and 3rd grade, Tunstall, kindergarten. How would you modify this lesson? And feel free to look up elementary globe. Why don't I just show it to you? Why not? See if I can get to it real quick. Here it is, Globe.gov. Here's the Globe website. This is the main website. And then you don't even have to sign in, I think, to search. Use the search tool. And then let's see. There it is, elementary globe. Pop right up. Elementary globe, boom. Search. And then here's the whole elementary globe page. And so here's clouds. And so here's the cloud book for elementary school students, and cloud fun, cloudscape. So all kinds of ways to get even 3rd graders to think about clouds from a scientific standpoint. And like I said, you don't necessarily have to have a whole science class, but if at some point you teach your students something about clouds, you never know. That might be a person that gets that spark, and 20 years from now, you'll see that same child on the Weather Channel, and they'll say, when I was in the 3rd grade, my teacher, Miss Robinson, taught me about clouds, and it just sparked my interest. And now I'm a meteorologist on the weather station, on the Weather Channel. And you're thinking, Dr. Padgett, that's crazy. That'll never happen. My mother taught 6th grade for 40 years. And even now that she's in her 80s, there are people who walk up to her and say, you were my 6th grade teacher 60 some years ago, right? People don't forget a good teacher ever. Do you? Well, you're still kind of young, but trust me, no matter how old you get, you'll remember that 3rd grade, 4th grade, 5th grade teacher that changed your life, changed your mind. I remember my teachers. Well, I remember my black teachers, Miss Johnson, right? Miss Johnson, I thought I was smart. I got Miss Johnson's class and I finished all the 6th grade work. She gave me the 7th grade book. I thought Miss Johnson was picking on me. I went home, I said, Mom, Miss Johnson's making me do more work. But my mother luckily was a teacher and she said, no, David, she's pushing you. She's pushing you. She knows you can do better than 6th grade. After I got finished with the 7th grade book, she gave me the 8th grade book. You know, whereas other teachers were like, oh, David, you've done so good. Go out and play. And now, not Miss Johnson. Miss Johnson made me much stronger, much better, much smarter. Right? I wasn't happy about it, but you remember those teachers that will do that for you your entire life, right? Your entire life, right? So anyway, um, so again, after you complete this assignment, upload the entire document to the Dropbox. And again, if you have any questions, let me know. This is recorded. I'm going to have to stop recording at this point.